Hello everyone. I hope you're doing well. In this video, I'm going to go over the loan payment formula. Just basically, we're going to go over the loans. When you borrow the money, how do you determine monthly payments? So we have some terms in here. PMT as the regular payment amount that you need to pay when you pay back. P is the principal, the initial loan amount. APR is the annual rate of the loan. N is the number of payment periods per year. This is going to be, in our examples in here, it's going to be 12. That's kind of like the reality right now in many cases. And the Y is the loan terms, like the number of years that you are going to pay back. So I have I have here like two examples, but I can say all the other type of loans goes in the same way. So you have the amount that you borrow at the beginning, and you have the rate, you have monthly payments, and you have the number of years, which is called the term of the loan, and then you determine the monthly payments. So even there are calculators for this that you can enter these values and it can give you your monthly payments. We're going to show you how the formula really runs in here. So the first problem, I just choose like two, one for the credit card loans and then credit card payments, and then the other one is simply the mortgages. So uh, you may think of this credit card in the same way if you're keeping a certain like balance all the time. Um, but this time you have a balance and you want to just pay it off. No additional charge, like no additional kind of like purchases are made with this credit card. So there's 5,000 in there, and you want to pay it off within 2 years, and the APR, the rate is 20%. Usually you just get this in between like 14 to 24%. So here it's just 20%. But this is, I just want to clarify, this is really same for um, all type of loan problems. Here, you can assume that you just get a loan of $5,000 and you want to pay it in 2 years. So that's just the same thing. So I plug this in our formula, so I can just simply get the formula from here. I'm going to plug in the numbers, but just be careful. These when you plug in the calculator, here my formula here is just given in that nice format that you put exactly same into the calculator. So, for example, for just like this one, we have $5,000 times we have APR, which is 20%. So you convert it into decimals, it's going to be 0.20 divided by 12 because you want to make monthly payments. So it's kind of like the regular way that you work and for the credit cards. You make your monthly payments here. And then that really says n needs to be 12, right? And in our examples, that's going to be the case. So it's just like real life problems. And then you divide it by bracket in the parentheses, just that's the same thing in the calculator. You use parentheses for the bracket. You don't use the actual bracket, but when we write it down to write this notation clearly, we use the bracket when we already use the parentheses. It's going to be bracket 1 minus parentheses 1 plus 0.20 divided by 12, and then raised to the power negative 12 multiplied by the number of years, which is here 2 years. I want to pay it off in 2 years. So I plugged it in. Now I'm going to show you this on a TI-8384, how you really plug in those numbers in here. So let me open my calculator. Here we go. So we're going to type this in exactly as it is. We have 5,000 times, I use parentheses, it's going to be 0.20 divided by 12, close the parentheses. So now I have division, divide, and then bracket, so I use parentheses again. I have 1 minus parentheses again, 1 plus 0.20 divided by 12, and then close parentheses. Now exponentiation, I need to use this caret and then open parentheses, it's going to be this negative sign, negative 12 times 2. And I close the parentheses of the exponent, and then I close the parentheses for the bracket. So I hope this is clear. And then I can hit enter, and that's my monthly payment. So I'm going to be paying rounded up to cents. It's 9, so I'll just round up to 48. So it's going to be $254.48. So that is why monthly payment amount. I pay this much per month to pay it off in 2 years. So I hope this is clear. So for example, if you get a loan from the bank with 20% APR, 5,000 that you are supposed to pay in 2 years, then this is going to be your monthly payments. This is all the same. All right. Next, it says, can you calculate the actual total amount that you paid? So total amount that I paid here in this problem, I have $254.48 per month. Okay. Times I have 12 months in a year, right? And then times I need to pay it for 2 years. So if you just calculate this, really, I mean, it's going to be simple, but if you calculate this, you're going to get the answer to be 6,107.52 cents. So this is how much you pay at the end of this term, 2 years. So as you see, remember 5,000 was the principal, right? So the difference will be the interest amount that you paid. So it's the interest amount that you paid, which is going to be the difference. So you subtract, so it's going to be 1,107.52. So I hope this is clear. So it's kind of like the difference amount. The additional amount that you paid will be the interest. So the last part, it says what percentage of your total payment is the interest. So you already find the interest, and you already find how much you paid total. So you just simply divide them. So it's going to be 1107.52 divided by $6,107.52. So I just divide these two. If we divide them, you will get 0.181, which is going to be, if you round it to percentage, if you just use it as a percentage, it's going to be 18.1%. So that much was the interest that you paid out of the total. So this is toward interest. And the remaining portion, like the whole is 100%, the remaining portion, which is 81.9%, right? This is toward the actual principal. So at the end of it, you can just do this analysis, and you can just see how much you really paid, what percentage you paid toward interest, and what percentage you paid toward the principal. So this is exactly the same for all kind of loan problems. This is same. Like if you take, let's say, 20,000 with 5%, this is exactly the same formula that you're going to use. So I hope this problem is clear. Now I'm going to move into the next problem. This is about mortgages. So for mortgages, it's just the same as the loan, but this time it's going to be a bigger amount. As you see, I mean, even right now it's much higher than this. But let's say you want to borrow money, a loan, $120,000, and I put here two different options. The first one is really simple. It's just this 30-year fixed rate, so you have 4% rate and no closing costs. I'm going to talk about that in a minute. So it's kind of like there's the term which is the closing costs. I'm going to just talk about that in a minute. But the first choice is the regular way that we use. The first choice, like choice one, is the regular loan formula. Choice two as well. So it's going to be 100 and so the monthly payments will be it's going to be 120,000 times the rate is 4%, 0.04 divided by 12 again because we're making monthly payments divided by bracket 1 minus 1 plus 0.04 over 12 raised to the power negative 12 times 30 years. Guys, I want to clarify, if you really practice this formula a lot, if you're using this in your course, if you practice a lot, at some point you will really get used to it and just write it down and just put it in the calculator really fast. So practice is really important for these kind of stuff. So let's put this on the calculator. I'm going to show you how it works. This is important. 120,000. I'm just writing down whatever I have in here times parentheses 0.04 divided by 12, close the parentheses, division, open parentheses, which is the bracket, 1 minus parentheses 1 plus 0.04, and then divided by 12, and then close the parentheses, raised to the power, open the parentheses, negative 12 times 30. And then close parentheses for exponent and close parentheses for the whole denominator. Now, if you have a TI-84 plus or just something higher, the screen, the actual format here will be much better. You can follow it easily from the formula. So you may just use, if you're using one of them, it's going to be much better, but this is what you have for TI-83 plus. So I hit enter. Oh, I'm sorry. Enter here. So that's our monthly payment. So we need to pay here $500, $572.90 per month. Now, in the second problem, the 3% rate is just like the same way that you do in choice two. So 3% part. So it's going to be monthly payments will be same way. It's 120,000 and then times it by 0.03 divided by 12 and then divide the whole expression by 1 minus 1 plus 0.03 over 12 and then raise it to the power negative 12 times 30. So it's just the same thing, that portion, like this portion, this part. It's the same thing. And if you compute this, well, I got this somewhere. If you compute this, it's going to be $500, $505.92 per month. So that's what you pay for the mortgage. Now, there's something else in here, which is called the closing costs. So this is like closing costs you just pay at the beginning of the mortgage. And this is the case for every mortgage, but here they try to distinguish on an example how really that affects. These are like one-time payments, one time that you pay at the beginning. So it's like you pay 1,200 plus 4 points means 4% of the whole loan amount, mortgage amount. So it's going to be 4% is 0.04 times it by the mortgage amount, which is 120,000. I hope this is clear. Not that much. Just like this is just a one-time payment that you need to make for choice two in this example. So if you multiply that one, this is going to be 4,800 and it's going to be 6,000 total. So 6,000 is kind of like your one-time payment, but you want to compare these two values over the long-term period. So it's kind of like this is going to be what you're going to be paying for 30 years. And 30 years is just 360 months. So it's kind of like, if you want to compare them, it's good to divide this one-time payment into a monthly payment plan. Like, you're paying this one time for a loan of 360 months. So what really that affects your loan monthly or mortgage monthly? So in that case, you need to divide it by 360 to see the effect of this cost monthly. So if you divide, you're going to get $16.67. So that's what you have per month. Of course, just you can say, hey, I'm paying this at the beginning. It's a little bit different. Yeah, we're going to talk about that. So you add this to the actual monthly payment amount. So it's going to be $16.67. If you add this, it's going to be $522.59. So yeah, the second option seems to be a cheaper option, but if you intend to stay in the house, like for example, if you have a possibility to move out of this house after 3 years, then that might be costly because you already paid $6,000 at the beginning. So this is the better deal if you really plan to stay in the house. If you do not plan to stay in the house, and if you really want to just, it's kind of like temporary short-term purchase, then the second option may not be good. But here, as you said, we're just doing this mathematically and just trying to compare the numbers. So we assume that the intention is just to stay, you're purchasing the house. So the second option seems to be better. Again, as I said, points. When you see the points in a mortgage, that means that point, so you write it as a percentage, and that percentage of the actual loan, the mortgage amount, will be paid at the beginning of the loan. So this is about loan formula. I hope this is clear. I hope you enjoyed the video. You can find like many examples in the web, and those are going to be really helpful, but they work with mainly with this formula, all the loans that works with this formula. So thanks for watching. Have a great day. Bye.